Hey, okay, today we will be looking at the cyclic sort pattern. मैं cyclic sort pattern सीखने वाला हूँ आज. Let's see what is cyclic sort pattern and उसके base पे some of the questions we will do and I'll solve in front of you here only. But I'll stop the video in between sometime as when as I stuck into it, as when as I'm thinking about it. Okay, where I stop the video and then again restart. Let's start with cyclic sort pattern. Okay, here you can see the. Okay, let's go back. What is cyclic sort pattern? Cyclic sort pattern is cyclic sort pattern. It's about the given numbers which may or may not be unique, but you have a range of numbers and then it asks you about those numbers. It can be anything, I don't know yet, but you are given a numbers. Like suppose, for example, if you say you have a list of numbers, no, you given that your array contains only numbers from 1 to n. Okay, 1 to n numbers it contains, and you given an array already. Suppose array is 1, 2, 2, and it can have duplicate, triplicate, whatever amount numbers it can have. And now you have to find the missing number. Find missing number. Find missing number, whichever is missing inside this thing that you need to find. Again, now one thing is we can look for, let's look at the simplest solution. Okay, solution one. And then solution one says uh, we have an array 1, 2, something, something, and then Saddam. And then I will check, I will create a new array that says missing number. Okay, suppose it's in pretty. What I'll do, I'll write a for loop which start from 1 and then end for n, and then look for 1 inside this array. Okay, 1 is present, yes, I don't put in missing number. 2 is present, yes, not put in the missing number. 3, oh, 3 is not present, then I'll put into the missing number. And that's how you will get to know. But it will take big of n square of time complexity, right? But there is another way to do it, because we know all the numbers present in this particular array. Okay, in this particular array, only uh, only have the range of 1 to n. So what we can do, we can utilize that fact, and that the fact says solution 2 पे चलते हैं उसके लिए अपन solution 2. And as per the solution 2, what we'll do, we'll create a new array. Definitely, it has the index from 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, n. And then what I'll do, I'll go through from this array I'll go through from, and then I'll say, okay, go 1 and I put this 1 at the place of 1, and then 2, 2. Okay, 3 is not present, I don't put anything here. Then 4 is not present, I don't put anything here. And 5 is present, 6 is present, 7 is present. Then next time I'll just go through, iterate this second array. Okay, and then I'll get to know, okay, this is missing, this is missing, this is missing. Big O fan. Pretty simple. So this is the cyclic sort where we will be utilizing the fact that we are given the numbers or given the objects which have some kind of ID, which is unique maybe, maybe it is present for in a certain range or something like that, right? Okay, let's look at the first question in it. So here we have given a question that says, yeah, that says we are given, okay, that says you have an input, the values inside input are unique, okay, and the values inside the input are unique, and those values only from the range of 1 to n. That's the certain part. And now we need to sort it. And there are some of the conditions that we need to look for. Okay. And yeah, let's go ahead. Can we solve it? Yeah, let's see. Okay, write down. I'm writing down the first thing, first array here already. Now, if you see, okay, now if you see, we have space conditions are space complexity, big of one we want, time complex that is mentioned in question, time complexity, big of n we want, and uh, one other condition is okay, all numbers are from range of 1 to n, and each number is unique, each unique. These are the things I know. Okay, and this is the given array, input array. Now think about it. How can I solve it? Right? So if you start looking into it, then you will see, okay, the first way is we can create a new array and then put it there. But that's not the solution here. But I think what I can do is 3, 1, 5, 4, 2. I know for certain that 3 is here, right? And if 3 is here, it is not its place. Its place is where it is placed. Its place is at the third place. Okay, 1, 2. Okay, let's name it. It's from 1 to n, so I will rename it as a 1. It's 2, it's 3, it's 4, it's 5. So these are the indexes. So what I'm saying, if I put the value at its index, it will become sorted, right? Because first index is 1, second is 2, and this, because then it will come sorted. What I'll do now, I'll try to do this thing, the same thing. So I'll put the 3 at the third index, first iteration, iteration 1. Okay. Iteration 1, what I did, uh, this place become empty. Okay, 1, 2, 3, 4, 5. 1, 2, 3, 4. This will become empty. This will become 1. This will become 3. And this will become 4. This will become 2. And I store this 5 in the temporary. Temp is barabar 5. Then I will say, think again. Oh, 5 is not its place. So I'll put the 5 at its place. So in the second iteration, okay, it will be empty. It will become 1, 3, 4, and it will become 5, and temp will hold the 2. Now you will say, okay, 2 is not its correct place, third iteration. Then we will put at its place, right? Then it will be empty. It will hold 2, it will hold 3, 4, 5, and temp will become 1. And in fourth iteration, we will do the same. Then its one's place is this 1, 2, 3, 4, 5. See, sorted. This is the thing, when you know certainly it will repeat itself. But It might be possible. There is one more condition that might occur into the system. That is, if you start with 2, 1, and then 3, 4, 5, look into it, what you will see. And if I do the same steps for this, then you will see where second is not its place. So what I'll do, okay, here I'll say it temp equals to 2 and make it empty. And then I will see, okay, now it is not its place. So it become 2, 3, 4, 5, temp become 1. And then next step, 1, this become, sorry, not doing in the same thing. So this will become 1, this will become 2, this will become 3, this will become 4, this will become 5. Hey, now I can hold 1 because 1 gone to the goes to this one, this place already. So I don't have anything in the temp. So my cycle breaks here and I have one. Okay, sorry, I did a mistake here. So in the question I was assuming these are not sorted. So 4, 5, 3. 4, 5, 3. Okay. Now you say कि 4, 5, 3 is not sorted and this is sorted part. So we need to take care about this cycle. Okay. So what I'll do, I will start iterating from here. This will become my temporary, and I will go through and try to update each and every one at index, and as soon as I reach the end of it, then I'll move this next one. If it is its place, then I'll move it next one. If it is its place, then I move to next one. If it is place, then I move it, and then it is done. And it will take care about everything. If the cycle is break early or not. I'll going to write a solution to it, and then I'll jump back. Okay, so here we have the solution. If you see, I wrote a one for loop which it goes to iterate from nums indexes, and then I am doing this I not equal to I plus 1, and up until it will set the initial state of I, it will go and update the nums values, and then as soon as it's set at the ith place correct value, it will go ahead and then it will continue doing it and it will sort it. Yeah, but there is one another way to do it, the same thing, but little bit less distracting, if you say, this one. So what it is doing is it is looking at the ith number. Here we are doing a two loops, though it looks like we are doing a two loops, but in a way they both are the one only. Okay, one iterates from I to n place, and if and but the second loop what it do, if the number is not present at its correct index, it will update it, right? But instead of that, you could do this thing also. You start indexing, and if the index and the value, and if the value is present at its index, then you update the index. If it is not present, then you update the value, and it you will do it again and again automatically. Someday, like after some time, it will going to update its ith position. As soon as that happens, this will take care of that. So the same thing we were doing above, but we were using two loops, but here we are not using two loops. In a single loop, you can do it. So that's the thing, nothing more. Okay, cool. Move to the next question. Okay, this is the solution. Next question. Here is. So we are given an array of containing n distinct numbers taken from the range 0 to n, since the array only n numbers, but the total n plus numbers, find the missing number. Oh, the same question we were thinking about. Find the missing number. What we can do? Find the missing number. Right. Mhm. Yeah. Right. 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 I'm thinking about. We might sort it somehow. If you see here, let's pick a array 4031. So 4031. Here is the array. And if you see, we know for sure there the all the numbers it contains is 0 to n, right? And the total numbers, the n numbers out of total is n plus 1 numbers, right? Find the missing number. So here if you see, the length of this array is 4. So it will only consist 0 to 3 elements. It might be possible it has the 4, right? But but that's okay. But that's okay. And now in our thinking, can we sort it? Yeah, now we are thinking about that. Can we sort it? Yes, we can, we could. What we need to do is, uh, I'm still thinking about it. Earlier, what we did, we were looking into the index and we were thinking if it matches the value, then we'll move ahead, right? That's the same thing we did earlier. Same thing I'll do here. But I will have a condition, one more condition. Okay. Okay. Why? Let me tell you why I need that condition at all. So, here we know, mm, we know, there is two ways. Let's go with the first way of doing it, first solution. And the solution says we will create a new array which have n plus 1 length. So 1, 2, 3, 4. So 0, 1, 2, 3, 4. And I'll put them at these indexes. I put this 4 here, 0 here. Okay, let me do, but let me change the colors of the pencil. So I'll put 4 here, 0 here, 3 here, 1 here, and I'll go through and I again iterate it this array, and then we'll find okay, this is missing. One way of doing it. But if we look into this way, you have the space complexity of big O of n, time complexity of big O of 1. That's the problem. We want a space complexity as a big O of 1. So how to do that? Yeah. So let's look into the second solution. Now again, now you have this array, 3 4 0 3 1. And now what we will try to do is we'll try to sort it in place, right? So you can see if I try to put this value at its index, we don't have it, right? Because the indexes are 0, 1, 2, 3 only. So now what I'll do, I will have two arrays, two variables. One is the temp variable and the another value is the uh, yeah, um highest number, yeah, highest number Lydia. So I'll say okay, the length of this is 4. If the number is matches the length, or if the number is matches the length, then I'll put it here. So 4 goes there, and this will become nothing, null only for now. Okay? And I'll say if it is a null, then move ahead. Cool. So okay, cool. I'll go here and then I'll check again. The these are not matching. So I'll go back. I'll go back. I'll say, okay, put it here. So I'll put the number. Okay. So 0 goes here, null goes here, 0, 1, 2, 3. Or maybe I don't need the highest also. Yeah, I don't need to do this only. Yeah, I don't need to do that. So what I could do instead, so I know the indexes. These are the indexes. Now what I'll do, write it here for. Now I'll do this thing. I will start from this index. I will check if the index is the value present at the index is matching or not. It is not matching. If it is not matching, then if this value is equal to length of it, यदि ये length के बराबर है, then what we'll do, we will we won't we'll don't do anything. We'll move ahead. Okay. So the condition is index equals to value or value equals to length. इनमें से कुछ भी है, then we'll move ahead. So in this pointer will move ahead here, here, right? 3104. And now if you see index is 1, so index is matching the value? No. So it now will shift the value, shift it, or yeah. So what will become? This will become look like this. 0 come here, 4 come here, 3 come here. Now, okay, this is matching this condition. So what I'll do? Increase the index. This way it will become simpler. So 3 goes here, 0, 4, 0, 4, and 1 and 3. Okay, still I'm here, still I'm here, right? So now I will say, okay, this is wrong places, start, 0 is correct place, 1 here, 4 here, 3 here, 3 comes here, again 1, 2, 3. I will say, okay, it is not move ahead, 0, 1, 4, 3, 3 comes here, and then we'll say it is its place. Cool, we are good. We will say sorted, right? Right. Now we need to find the missing number. So we'll start here. If something is not present at its index, that means that index is not present, available in the array. 0 is present, okay. 0 is present at 0th index, 1 is present at 1's index, 4 is present at the, so that means 2 is missing. That's the solution. Now I will be writing a code for it. So I think I need to stop the video. Okay, cool. So now I had write it down the solution. Here you can see it is the same as earlier we were doing. So here we have a while loop and there is a condition which check key the value present at its index is same or not. If it is same, then we are increasing our index. But here we have one more uh, condition that says ki if the value is length of the number, that is for this 4, right? This 4, because it can't be present at its index. Okay, so if that is there, then we also increase our index. And else may it is the part is the same, we are just replacing these values. Okay, like if our index is at 3 and we know it's not at its correct index, so we'll replace it with 1. because three's correct index is which is present at 1, so we'll replace it. So that is we are doing here, and after it will sort it, and then we are again reinitiating a while loop, and we are checking until the numbers are the same, index and values are the same. We are increasing it and returning the I wherever it breaks. So that's the solution for this one. Let's move to the next question now. Okay. Okay. So this is the problem. We are given an unsorted array containing numbers taken from the range 1 to n, and the array can have duplicates, which means some numbers will be missing. Find all those numbers. Okay. We can start with a simple thing. Hmm. And the simplest solution what it could have. This is the same problem that we discussed already when we were looking at the cyclic sort pattern. I picked this issue or this problem only, and I solved it earlier. What I did is I solved it by using okay, let me just start follow the Visanalum. Okay, now cool. So earlier what I did is I created a new array, and at its indexes I was pushing the num values. If you see here, we have 2, 4, 1, 2, right? And we know for sure that the ranges from 1 to n, definitely 1 to n, right? And these values can be duplicate, that we know for sure, right? And now if that is the case, then we need to understand it. We know the length of this is 1, 2, 3, 4. So length is 4. So I expect it will have four numbers, and those four numbers are 1, 2, 3, 4. That what I expect. But in reality, it is true? No, because 3 is not present here. How can I find it? Brute force solution. I look for 1, look for 2, look for 3, look for 4. That we don't do. So what I'll do instead, I'll create a new array, right? Sorry, it's big one. 1, 2, 3. So I create a new array, and I'll say 1, 2, 3, 4, maybe 4, and I'll push the values at its index. So value 2 will goes here, value 4 goes here, value 1 goes here, value 2 goes here, and then I'll start from the I1th index and then look for okay where it is present. Cool. That's what I'm gonna do. So I'll create an array. Okay, length of n plus 1, because this will be empty, and then for loop, and then iterate iterate on nums that is given to us, this nums value, and push values at new array, then again iterate on new array and look for missing numbers. That's what we're gonna do here. So I'm pausing the video for a second and then it start implementing it. Okay, so for this solution, as we discussed earlier, as we already discussed here, so this is the This is the our pseudocode that I can't understand right now. But yeah, that is so actually we will be creating a new array of length n plus one, and then what we are going to do is we will be pushing the values from the nums. These are the values. Instead of I, what we can do, say value at its index, whatever the index is, and we are pushing it. And then we are checking if the index is undefined, at anywhere it is undefined, then we'll push this index into the missing number. That means it is not present, right? So that's what we discussed earlier. But the problem with this is if you see clearly, the problem with that is that it is taking a time complexity of big O of n. So, sorry, space complexity is big O of n because we are creating a new, right? So we are creating a new array and the time complexity is also big O of n. But we can solve it in a big O of n space complexity. Let's try to do that. So for that, what we can do, if you look into it, like 2 4 1 2, that was the case, right? This is our array itself that says 2 1 4 2. Now, earlier what we were doing, we were sorting it out by using replacing the values at its index. Same thing we'll do here now. Yeah. So we start from this one and let's replace it. So let's assume indexes starts from 1. So 1 2 3 4. So these are the indexes. Okay, let me 1 2 3 4. These are the indexes, and now we will be switching it. So 2 is not its correct state or correct index. What will I do is I'll replace it and put it at its correct state. So here it become 4, this will become 2, and this is 2 2 3 3, right? And then let's go to the next state. Let's go to the next iteration, and our index will be there only. Okay, because until or unless it matches its index, this value matches its index, it won't go ahead. So it's 4. So what I'll do? Okay, now I'll repeat push this at 4. Okay, and then this 2 will come here, and this 4 goes there. 2 2 1 4. Index is here, is still here. So then you will see, okay, uh, condition is clear, right? Index equals to value, index equals to value where I will increase the index I value. Okay, move to the next one. Here you will see index is 1, value is 2, not matching at all. But when you try to repeat, see it, you can move this and use this, move this. But this is a rotating condition. It will again occur. So what we can do, if these two values matches, will make this one null. So we will make it null and 2 1 4. And if this value is matches its index or it is null, then we'll move ahead. So in condition changes a bit. Index is equals to value, or or value is null. In both cases, में will increase the index. Okay. So now increase the index. Now you will say, okay, it is at its correct index 2 2. So I'll move ahead, and then you will say the index is 3, value is 1, not matching, so I'll replace it. So 1 will goes here. So 1 2 null and 4. Now again this is null, move ahead. This is 4 and it's its correct state, and then move ahead. and then now it is sorted. And the next iteration, what I'll do, I'll look at it. If a value is present its correct index, then we will say, okay, yeah, now it is correct, so it is not missing, and then we'll go until we find some missing values. So same thing we will going to do here. I already wrote the code. Let's see that. This was the older thing, and this one is the new one. So this is the while loop. I can remove that though. Okay. This is the while loop. Pretty simple as it is as we were doing earlier. If the index I is equal to the value, or index I is the value is itself null, then what we'll do? I plus plus. Else there are two conditions. Remember, the value wherever we are replacing it with is the same to the from where we are replacing it. So जैसा हुआ था टू टू के साथ, right? So we have two condition. We are storing temp equals to numsci. If the replacement and replacee both are the same, then we'll set the replacee as a null. Else we'll do the same thing as we were doing earlier. And this is how it will sort it out. And at the end, we will iterate over the nums and then we'll got the missing values, right? And that's it. Let's move to the next question. Find all missing numbers. Okay, yeah, this is the one that we already looked. This is the solution for that. Okay, what I'm doing, I'll going to look at this solution, how it is doing it. I don't know. Okay, I'll tell you in a minute. Okay, one interesting thing by looking into the solution I found is what we were doing is we are checking for this specific condition, right? Ki if those replacee and replacements are the same, then num become null. But you don't need to do that. You kind of solve this issue without this. How they are doing is, what they are doing is, they are just looking at if the numbers are not equals to, right? These numbers are not equal to, then they are replacing or swapping the values, else they are just increasing the index. Okay. So what it will do, it will increase the, okay. Instead of null, you will be having duplicate values, but those values won't be present at the its correct index. That's what it do. And the same thing, the for loop we are doing here, as we were doing earlier, and then this is the missing number. Cool. So we solved this issue. Next, move to the next problem. The next problem says we are given an unsorted array containing n plus 1 numbers taken from the range 1 to n. The array has only one duplicate, but it can be repeated multiple times. Find the duplicate number without using any extra space. You are, however, allowed to modify the input array. I think I kind of solved it already, right? And do we need to do it again? The thing is that. We are given an unsorted array containing n plus 1 numbers taken from numbers n plus 1, and the array has only one duplicate, but it can be repeated multiple times. Find that duplicate number without using any extra space. Okay, it is the same issue as we did earlier, so I'm just copy pasting the solution here itself. Right. But here we need to just find the number itself, not there won't be that much missing numbers, right? So I will say, okay, sorry. I will say we are going, if it is not equal to n plus 1, then we'll return, I. Simple as that. Right. So let's try to run and see. Good work. Uh, Something is wrong. Expected output is 5, expected is 3. Okay, let me see what is the issue, but that is the solution for it. Yes, I think I was misunderstanding the question. So the question was about to find out the duplicate number, not the missing number, right? So, okay. So how can we do that? It's pretty straightforward. So earlier we were looking here that nums I equals to times I. That is what it was about the duplicate number. And as soon as we find it, we'll return it. Not need to do anything else at all, right? So this is the solution and it is working fine. The same thing as we were doing earlier, nothing else. Okay, let's move to the next problem and how they are doing it. That's interesting. So a while loop, if it is not equals to I plus 1, then they are doing this nums. If nums is not equal to, then return n plus. Ah, the same thing as we were doing. Yeah, exactly same. Next, move to the next question. The next question is about we are given an unsorted array containing n numbers taken from range of 1 to n. The array has some numbers appearing twice. Find all these duplicate numbers using constant space. Okay, okay. We need to find the all the duplicate numbers. Okay. Uh, yeah, let's do that. Not a big issue. Let's look into this question. Okay. So if you see the question correctly, this array will have 1 to n numbers from 1 to n. Their possibility is there are multiple numbers which are duplicate. Duplicate only twice. There can't be possibility that 3 comes at 3 times. No, that's not the possible. They are present the 2 times only. Okay, they are just a duplicate. They are not triplicate or quadruple. So they are just a duplicate. Okay. And then range is 1 to n. They are just duplicate. And then we need to find the duplicates only. So this is the thing. Earlier, what we were doing is we were thinking, okay, don't think about that. So if you try to sort it, what will happen? Uh, okay, solution one. Solution one. Solution one says you just sort it and you will get to know how many duplicates are. You will sort it, so it will become 2, 3, 3, 4, 5, 5, 7. So you will start from here. Okay, 2. And is the next one is same? No. If the next one is same, yes. So 3 is duplicate. Then next one is the same, and then we'll go to here. Next one is not same. Go to here. Next one is not same. Next one is same. Yes, 5. Next one is not same. Then we are done. So 3, 5 is duplicate. So to sort it, we need to do a analog and time complexity, right? So, okay, but we have a better solution to that than that we were doing earlier also. And the basically solution is sort it, but with the cyclic sort. And because we know it is a range of numbers, so what we can do is we will create an the same thing 5, 4, 7, 2, 3, 5. 3. Sorry, doing wrong. I just need to write 1, 2, 3, 4, 5, 6, 7. 3, 3, 3, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6, 7. These are the indexes. And right now, if you see 5, 4, 7, 2, 3, 5, 3, these are the okay. These are the numbers. Those are present in this index. We'll start sorting it by using the cyclic sort. Then we'll see, okay, 5 is not at the correct place, and then we'll put it at the correct place. Okay? Then we say, okay, 5 will go here, and 5 will go here, and 3 will come up here. So 3, 5, and other things will remain as it is. And then we'll see, ask for 3. Okay. 3 is not at the correct place, then it will goes here, 7 comes here, then it is not correct place, then it goes to the 7 and it will become 3. So 3, 7, 5, 5, 2, 3, 4. This will become our new array. And here you will see, okay, 3, 1, 2, 3. So 3, if you try to replace it with this, that's not correct. So we'll move ahead. Instead of putting here null, we'll move ahead. That's the point where we can solve it, right? And and then we'll get a new array. Okay, let's see what it will become. I'll try to do that. And then it's become we reach here, it is not correct. Then 4 goes here, 2 goes here. It is correct, it is correct, it is correct. Then 5 is correct, 6 it is not correct, and but if you try to move it here, it is the same, so it moves here, then it is correct, then that's that. So our new array become 3, 2, 3, 4, 5, 5, 7. And now we need to iterate it from here and then see if the index and the value are same, then it is not a duplicate. If they are not same, then it is a duplicate, because it is not same, so 3 is duplicate. It is same, it is same, it is same, it is same, it is not same, it is same, so 5 is duplicate. So here we get the answer. So this is the how we can solve it. And now I'm just trying to implement it. So here is the implementation. Is the same that we have a while loop which iterate over the nums while it is looking at the if the replacement and replacee is not equals to, then it will replace swap them, and if that's not the true, then it will increase the I or index, and then it will give you a sorted nums, or not sorted altogether. They will be sorted, but they have in between duplicate numbers. And if the value and its index are not same, that means the value is a duplicate. So we are pushing it into the duplicate number, and then we are returning duplicate numbers. That's how we did it. Let's see how this they are doing it. Looks the same, exactly looks the same. Instead of temp, they are using J and nothing else. Okay, everything is good. Let's move to the next question. Okay, so next question is about this unsorted array. Here is this range of the values which are lies from 1 to n, but it says that due to some corruption there is one value is replaced, then you have to return the duplicate value and the missing number. So this will become our output and this is our input. So if you see, it's the same thing, we just need to find the one of the yeah, so yeah, we can just copy from the last thing and then just try to update this solution a bit so it can go into it, right? So I'm doing that. Just yeah, I'm doing it now. So I pasted here, it's the same thing as we were doing to find the duplicate numbers. And here we sorted it first of all without setting it null. And so we sorted it first, and then we are looking into it. If the num size is not, if the index is not equal to value, that means value is the duplicate value and index is the that is missing, right? So that's we did here and then submit it and yeah, it's successfully accepted it. Let's go and look how they are doing it. So same thing, they are just replacing the values with its index and then they are looking into it and then yeah, returning the nums. Yeah, exactly same. Next question. Yeah, next question is find the smallest missing positive number. So given an unsorted array containing numbers, find the smallest missing positive number in it. The positive numbers start from 1. Okay. Given an unsorted array containing numbers, find the smallest missing number. Missing positive number. Okay, smallest missing positive number. The smallest missing positive number is 3. Okay, so we need to just sort them. Okay, yeah, we just need to sort them, put in an array, and then see which is the missing smallest sorted number. That's it. Nothing else we need to do is okay, cool. So how can we do it? Yeah, no, good question. How can we do it? Okay, let's go to this thing. So if you see here, we have -3 1542. -3 1542. If you look into it, then you will think कि just saw them. Sort करने के बाद look into it. If there is a missing number, then yeah, you done it. Okay, sort first solution one, right? Solution one, solution first. तो -3 1 2 1 2 4 5. You will go ahead the increasing number and then you will see okay 2 के बाद 3 आना चाहिए but it's 4 so 3 is missing. First solution n log n, but we don't want that. Exactly, we don't want that. So what we can do is we move to the solution second. Okay, solution 2. Solution 2 says we can use cyclic sort. What we'll do, if the values are negative, then we'll don't do anything. If the values are not negative, then we'll put them at their indexes, right? So suppose the index, I'm writing the index 1, 2, 3, 4, 5. So we are here, and so then we'll say it's -3. We'll go ahead. And then we see it's 1, तो 1 यहाँ पे नहीं होना चाहिए, 1 यहाँ पे होना चाहिए, तो we'll say कि 1 यहाँ पे आएगा and sorry 1 यहाँ पे आएगा, -3 is go there and then 4 5 2 and this is -3 now and we'll move ahead because it is negative. 5 is not at correct position, so we'll replace them. 2 यहाँ पे गया, 5 यहाँ पे गया. Then we'll see okay 2 is not its correct position, we'll replace them again. 2 यहाँ पे गया, -3 यहाँ पे आ गया. Okay, then you will say it's negative, move ahead. It's 4 4 सही जगह पे है, 5 सही जगह पे है, then it's done. So it will become 1 2 -3 4 5. So we will check if from the fun, if the indexes are matching. If whichever index is not matching, that index is the minimum positive number, right? Done, sorted. Let's do that. Do I need to write the logic again? Yeah, I'll do that. So here is the implementation, the same thing. We just do a cyclic sort here, and after doing the cyclic sort as we were doing earlier, The thing is, we need to look for the negative numbers also. If the numbers are negative, then we can't do anything with it. We just increase the index. Else we do the same thing and then we'll look for if the I is not equal to I plus 1, then we'll return I plus 1. That is the missing number, right? And it is solving it. So let's see how they solved it while j and then greater than 0 and nums less than I. Okay, cool. No problem. The same thing. Okay, now we move to the hard question, that is to find the first k missing positives. Okay, so given an unsorted array containing numbers of a number k, find the first k missing positive numbers in an array. Okay, explanations. Smallest missing positive numbers are 1 to 6. Mm, cool. So yeah, so I'll pick this thing and then I'll try to tell you what is the difference between this question and the previous question and why it is a bit harder than that. Okay, so if you see here, so this was the given to us and it is asking we need to find out the first uh, k least positive number. So if you try to s- do solve it, what you will do? Maybe you just go sort it and then solve it, but that's not the way we will going to do. We will use the cyclic sort. So in the cyclic sort, what will be become the answer for this situation? Okay, one. I'm just writing the indexes 1, 2, 3, 4, 5, right? And suppose k is equals to 3. These are the numbers that we need to figure out. Okay. Now, now, if you start doing it, then you will find, okay, this is our first index. It is not at its correct index. Then I'm just doing the cyclic sort here, and then we'll see. Okay, 4 come here, 3 goes there. This is not the correct position. Okay, I'm just doing in place only. 4, 5, 5. Now I'll do. Okay. Okay, so 3 was here, no? Yeah. So 1, 2, 3, 4, 5. So 3 is not at the correct place. It will goes there. 4 comes here. It is not at correct place. 4 goes there. 5 comes here. It is not correct place. 5 goes there. Okay, now you will see it's they are same. We need to think about the sameness. If they are same, we'll move ahead. Cool. Move ahead. And then this was 1, so it will goes here. 5 comes here. It is not same, then we'll go ahead. So you will see it is same, it is same, it is same. So now, where is the minus 1 goes? Oh, it's okay. If minus 1 was there, okay, sorry. I missed one thing by the way. Again, I need to do it again. Whole thing I need to do again. So 3 minus 1, 4, 5, 5. I was thinking this is a 1, but I was wrong. 1, 2, 3, 4, 5. Now let's start doing it. So it is not correct place. So 3 goes here, 4 comes here. Okay. And now it is not correct place. So 4 goes here, 5 comes here. It is not correct. So these are the same. So we'll move ahead. So it is 5. Finally, it become 5. Yeah. then it is negative. We need to consider the negative also. If it is negative, then we'll move ahead. We don't do anything at all. And then correct, 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 and everything is good. Now, these are not matching. That means one is missing. These are not matching. That means two is missing. Matching, matching, matching. Now, but they ask, we only have two of them. They ask three. So what we will do is, whatever the next is, that will be the more than five. So six, seven, eight, depending on the k, we'll add that. So cool. So this is the thing. Here we need to consider the same values. Here we need to consider the negative values. Here we need to consider that it might be possible those are the absent values. The k is greater than that, then we have to extend our absent values inside this. So that's why it's a little tricky question if you look at the first time. So now we will write. So here is the implementation. Earlier, the same thing. We just do the cyclic sort. And after the cyclic sort, there is one interesting thing about the next number. Okay, if you see here, uh, here we know one, two. Okay, let's clean it a bit. Okay. After the cyclic sort, we get here 5 minus 2 minus 1, 3, 4, 5, right? So my question is, now we know these are not matching, so this will become one, first missing number. These are not matching, two is become missing number. Then this is matching, this is matching, this is matching. How you will track what is the last biggest number that is present? So for that, you might think, okay, we'll pick the length of it, right? So you were thinking 0, 1, okay, 1, 2, 3, 4, 5. So 5 is the length of it. So 5 will be the biggest number. That's not the certain case. It might possible. Here you have some negative number. It might be possible. You don't have the 5 at all. You have 2, 2 here. So the biggest number is 4, right? So there is some issues. So we need to track the next number also. Okay, so for that, what I'm doing is we have created one birth variable, next number. If these are the not equals, then we are pushing the value that is the missing number. Else, we are setting the value as to the next number because it is present. And then, if the next number is never set, then it will be 1. And if it is ever set, then it will be next number is plus 1. Because we don't want to push the 5 in it. The next number will become the 6. So, and then we are doing this. If the while missing number is less than k, then we are just pushing the next number into it and then increasing the number, and that's it. And this is the solution to it, and we solved it. Okay, cool. And let's look into their solution, how they are doing it. The phase one, rearrange element to their correct position. So that is the cyclic sort. We also did the same. Rearranged it, and then let missing number, extra numbers. Okay, new set we are creating. Identify missing and extra numbers. So missing numbers, it is pushing. Okay, it is pushing. It is not looking for the next number at all. If the missing number is length is okay, cool. Find the remaining missing numbers. So for that, what it is doing, it is looking at the missing numbers there. Okay, if extra numbers dot has candidate numbers, missing number dot have push candidate numbers. No, it is doing something with the candidate number. We don't need to do that. We can do just whatever I'm saying, right? Okay, cool. So this is how we completed our cyclic sort. And the next thing, the pattern is we will be going to the linked list patterns. So I think for today it's good. We solved some of the problems related to the cyclic sort, and we understood how the cyclic sort works. Okay, cool. Thank you. Bye bye.